a very handy lemma in a variety of cases. It says that there's a smallest intersection distance when you have a finite open cover. We used this idea when we showed that continuous on a compact set is uniformly continuous. But it's true with surprisingly little structure, and we'll make a more optimal function to find the delta. Compact with an open cover, finite subcover, call them the A sub I. What we want to do is measure the distance from the nearest A sub I, so we want to look at the complement sets of the A sub I. Bunch of closed things. And we're going to make a function from this compact set to the reals. We're going to take the average distance from x to the boundary of the A sub I. The distance function is continuous. A linear combination of continuous things is continuous. X has to be in some A sub I. So the distance from that x to the boundary of that has got to be a positive number. F is a continuous function on a compact space, so it attains its minimum. That minimum, delta, must be a positive number. Let's look at a picture for what's going on here. So we'll do 3 sets. So I'll set up 3 open sets. I'll set up a black one and a blue one and a green one. Pick a point in the intersection of all 3 and measure the distance to the complement set. Measure the distance to the complement set. Measure the distance to the complement set. Take the average. That's the radius of the ball that'll guarantee lie inside. Lies inside A1 in this case. Now we just got to formalize that picture as a proof. So we'll start with a subset whose diameter is less than delta. Diameter meaning the ball that contains the set. So if I take the supremum of the distance of any 2 points in the set, it's inside that ball of radius delta. So the x doesn't have to lie in the subset, but it does lie in at least one of the a's. F of x has to be bigger than or equal to delta, the minimum number, and by the very nature of an average, some element that you're averaging has got to be bigger or equal to the average. And x has to lie in some of the AI. Well, that's our picture. Delta, the distance, is smaller than the distance to the boundary. So the ball of radius delta is inside A sub I. So for that I, capital X is a subset of A sub I.